Hey guys, so this is a continuation on the topic of trigonometry. This is trigonometry part 2. If you did not watch the first video, I highly recommend you watch it because a lot of the concepts discussed in those videos, in that video, in part 1, going to be discussed in future videos, okay? So it's really good if you watch that one before you watch this one. So let's get right into this one, okay? So when we're doing topics of trigonometry, we need to be able to find the value of the sine, cosine, and tangent for important angles, okay? There are a few important angles I need to know. They are normally 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, okay? Now, the one for 0 and 90 degrees, you normally have to learn off that one. Usually, it's best to get it from the graph. Um, in that case, it's normally either 0 or 1 if the angle is 0 or 90 degrees. Okay, the angles for 30 are the answers for 30, 60, and 45 degrees tend to be a bit more complicated, okay? So I'm going to show you how to find the angle, the values for sine, cosine, and tangent when the angles are 30 degrees, 45 degrees, and 60 degrees, okay? So let's get right into this. So, firstly, how we do it is we have started with a triangle, okay? In this triangle, we're going to be an equilateral triangle, and each side going to be of length 2, okay? So what we're going to do now when we have this triangle, okay, notice that all the angles are 60. We're going to draw a line, okay? We're going to draw a line coming down in the middle, directly in the middle, okay? No, notice now here, so it's a 90 degree, okay? Notice here now that this angle, if we split 60 in two, this angle is actually now 30 degrees, okay? And since this here now would be split, okay, into one, since it's directly in the middle, and this here would also be 1, okay? Now we need to use Pythagoras theorem to find the length of the line the dotted line we just drew, okay? So using Pythagoras theorem, we get 2 squared is equal to 1 squared plus, let's call that line x squared. So therefore x squared would therefore be equal to 3, and therefore x would be equal to the square root of 3. So the length of this line here is actually the square root of 3, okay? So now we have all the lengths. We know the length of the hypotenuse and the two other lines. What we can do now is actually find the sine, cosine, and tangent for the angles, okay? So let's start off with 30 first, right? So starting off with 30 degrees, sine 30. Remember, sine 30, sine of an angle. So where's the 30-degree angle? The 30-degree angle is here, okay? So this is our reference point. So in this case, this would be our opposite, this would be our adjacent, and this would be our hypotenuse, okay? This is our adjacent, and this is our opposite, because this one is opposite the angle, okay? So sine 30 now, sine is so opposite over hypotenuse, so it would therefore be 1 over 2. So sine 30 is a half, okay? Cosine 30 now, okay? Cosine 30 would be equal to the adjacent over the hypotenuse, which would be equal to root 3 over 2, okay? Tan 30 now is equal to the opposite over the adjacent, okay, which would be therefore equal to 1 over root 3. Now, an important thing to note is that the value for sine of an angle is always between 1 and 0. The answer for cosine of an angle is also always between 1 and 0. If you want to find the sine of any angle, they would always give you a value between 1 and 0. Okay, if you want to find the cosine of an angle, it also always give you a value of between 1 and 0. Okay, so now we're going to deal with 60. Okay, so we're going to find sine 60 now, okay? So now when we're dealing with sine 60, this line here actually becomes our adjacent. Okay, this line here becomes opposite since it's opposite the angle, and the hypotenuse remains the same, okay? So sine 60 is opposite over hypotenuse, which should be equal to root 3 over 2, okay? cosine 60 is equal to the adjacent over the hypotenuse, which is equal to a half. And then tan 60, tangent is opposite over adjacent, which is equal to root 3. Okay. Now, an important thing to notice that sine 30 is equal to cosine 60, and cosine 60 is equal to sine 60. Okay. An important rule to remember is that sine theta is equal to cosine of 90 minus theta. Okay. So, for example, sine of 5 would be the equivalent, would be equal to cosine of 85. And in the same sense too, cosine of an angle theta is equal to sine of 90 minus theta. Okay. In this sense now, we would also expect that sine 45 and cosine 45 would be the same. Okay. So this is how you find it for 30 degrees and 60 degrees. Now we want to move on to 45 degrees. So for 45 degrees, we're going to start with an isosceles triangle where we have two equal angles of 45 degrees. If here is 1, length is 1, and here is also 1. Using Pythagoras theorem now, we'll find, let's call that c squared. We're going to find length of the hypotenuse would be 1 squared plus 1 squared. C squared would therefore be equal to 2. Therefore, c is equal to the square root of 2. So therefore, the length of this hypotenuse line here is the square root of 2. Okay? So we're going to find now is sine 45. Okay, sine 45. Again, remember, in this case here now, we could either way, whichever angle we use, we're going to get the same answer. Okay, because remember, sine 45 and cosine 45 is the same. Okay, so using any angle, if we find sine 45, we'll get 1 over root 2. Okay, if we use cosine 45, okay, we'll also get 1 over root 2 as expected. And if we use tangent of 45, we'll get 1. Okay. So normally, so these things here, you see the answers for sine 40, for 30 degrees, 45 degrees, and 60 degrees, you normally have to memorize it. Now, if you have a sharp calculator, you definitely will need to memorize these. However, if you have the Casio calculator, it tends to give you the answer in these forms. So in that case, you won't have to memorize it. So I highly recommend you use the Casio calculator. It's much easier to use. It helps you. It gives you answers in fractions. It could also factorize, do simultaneous equations, and so on. Okay. Now we come to the last part of this video, which is radians. Okay. Just like how degrees Celsius and degrees Fahrenheit are both unit for temperature, just so degrees and radians are also both units for angle measurement. Okay. And in this case, 2 pi radians, so we normally use pi when representing radians, okay? 2 pi radians is equal to 360 degrees, okay? Therefore, this would imply that 1 degree would be equal to 2 pi over 360, which is equal to pi over 180. So just like our circle is 360 degrees, it would also be the same as saying 2 pi radians, okay? And to convert between them, 1 degree is equal to pi over 180, okay? Now, an important thing is that we need to know how to convert for the major angles as well, okay? That's really where you will encounter it. So we're going to know 45 degrees, 30 degrees, and 60 degrees. 45 degrees would be the equivalent of 45 pi over 180, which would be equal to pi over 4 radians. 30 degrees will be same as 30 pi over 180, which is equal to pi over 6 radians. And then 60 degrees would be 60 pi over 180, which would be equal to pi over 3. Now these are the most important ones, okay? These 3 angles we need to be able to know how to express them in both radians and degrees because they'll come up a lot, okay? So again, 45 degrees is pi over 4, 30 degrees is pi over 6, and 60 degrees is pi over 3. So if you want to convert degrees to radians, just multiply by pi over 180. And if you want to do it the other way, just multiply, if you want to, so to go from degrees to radians, okay, we want to multiply by pi over 180. And to go from radians to degrees, okay, we multiply by 180 over pi, okay, and that's how you convert between radians and degrees. Now, an important thing now, your calculator is designed to work in both radians and degrees. However, yeah, be careful of the mode that you are in. If you're doing a question in degrees, make sure that your calculator is in degree mode, normally represented by DEG. And if you are doing a question in radians, make sure, and then you have a pi in it, make sure that it is in radian mode, normally indicated by RAD. If you calculate an angle in radians, it will not give you the same answer in degrees. So you need to make sure you're in the correct mode in your calculator whenever doing trigonometry questions. A very, very common mistake is that people mix up the modes on the calculator. They forget to change the mode on the calculator and they end up with the wrong answer. You will end up with the wrong answer if you are not in the correct mode. Okay? So just make sure when you're doing questions, make sure that you're in the correct mode. And always check before you start the question. See whether they're working in degrees or radians, okay? So that was it for this video. You learned how to find the sine, cosine, and tangent of major angles, as well as the unit of radians for measuring angles, okay? That was the end of this video on trigonometry part 2. Look forward to the next video, trigonometry part 3, and I hope you learned something in this video. Thanks for watching.